Hello friends, welcome to my channel. So in this lecture, I can discuss with some of questions which is belongs to the named reactions. So will you see this kind of questions in any competitive exams? Yes, we'll see any competitive like CSIR, NET, GATE, JAM. This kind of questions previously they're asking this kind of questions. So now I am going to explain full mechanism of these reactions. What is the product we'll get, we'll see while doing the mechanism. Even though when you are writing competitive exams, if you know the answer, please complete. You should write the mechanism. After that, you can keep or you can choose the answer without practicing, without write the mechanism and without prove the answer. Simply you are keeping that answer is mostly you will get negative marks, or there are a negative marks, right? So it is better to write a total answer, because if you keep the answer above the plane, actually answer is below the plane, but in one small mistake just to you can keep the answer in above the plane, so it should be 0. You will get 0 marks on that. So completely you should write the answer before you are writing the competitive exams, right? So blindly you will not select any questions answers in a competitive exams. So we'll go to reaction in this. So what is the product we'll get, we'll see one by one. So here you can see in this reactions events auxiliary chiral molecules which is in aldol reactions. So this is the base, right? What is the purpose of base? Actually it is take the abstract the protons, where it is abstract the protons which is in acidic media. So here we have a acidic hydrogens, right? So this base will take the protons from here, then we can get the compound is like. So stereochemistry is most important while writing products, right? Here we'll get a negative charge, and if you see this negative charge is attack on in this position, so this three member will leave and this bond is migrated towards the oxygen. Then we can get the product is. So how it will going to attack, whether below the plane or above the plane? How? If you see here we have a below the plane, right? So it will attack on the above the plane. If it is above the plane, it will attack on the below the plane. If it is below the plane, then it will attack on the above the plane. So here we have a CH2, here below the plane O minus, and here we have a one more CH2 and TSO, right? So total 1 2 3, 1 2 3. Okay, next, this negative charge is attack on this carbon center, and this is good leaving group, this group will leave. So we'll get the product is, it's very simple reactions once you know the reaction mechanism. Don't buy hard anything in organic chemistry, you can understand. So here in above the plane, one CH2, again one more CH2. So here we have O. So this is for what? Our product, right? So here don't this is bond, and here we have a below the plane, right? So this is for what? Our product. And next to move to another name, one more reaction. See here they are giving a one 6-membered ring, one junction. In that junction here double bond. First it is treated with a diborane THF, and next H2O2 peroxide and NaOH. So again it is treated with PH3P det and 4-nitro benzoic acid. And third one is basic media. See, K2CO3 is a basic and methanol is dissolving in a methanol. Potassium, no, potassium, potassium carbonate is dissolving in a methanol, then we can get basic media. See, first borane, diborane, it is dissolved in a THF. It will using THF, then we can get stable. So first it is treated with a BH3. So how it is treated with a BH3? We have a above the plane. Sorry, we have the above the plane, right? So how it will attack? Below the plane. So here we have a BH2. So again it is treated with a water, peroxide. Then we can get OH. This you will learn in a reagent chemistry. Here you have a OH. Junction, right? Again it is treated with PH3P and dead. I said many times to remember one main key point of in named reactions. So what is this named reaction? Anyone can guess? When you see PPH3 and dead, simply you can say this is Mr. Noble reactions. 100% inversion product will get, right? 100% inversion product will get. So I will write here again. So here we have a OH. It is treated with 4-nitro benzoic acid. This is the benzoic acid 4-nitro, right? So here OH, H, water molecule will remove. So how it is going to add? It is a above the plane, it is a below the plane. So if it is a below the plane, it will attack on the above the plane. Right? So here we have a above the plane. So C double bond O. Here we have a benzene ring and NO2, 4-nitro benzoic acid. If you see, it is treated with a K2CO3 in a methanol. It will act as a base. So what will do the base? Here H, here OH, it will going to leave. Then we can get the product is, final product would be so this is for what our final product, right? So if you see in competitive exams, they are try to give this OH is one is above the plane and one is below the plane. So please don't be confused. If you know the answer, then simply don't keep any answers in a competitive exams. You can make that. You can you can write the mechanism. After that, you can keep the answer when you will get 100% confident about that reaction. And if you see one more reaction, so here third reaction, here it is having a benzene, SiMe3 and OH. Here we have a OH, BNO. It is treated with, first one is KH, THF and second one is MCPBA. Then we can get product. What is the product we'll get in this reaction? You can see here, first reaction is when you see this SiMe3 and OH, so this reaction is called, anyone can guess this reactions? What is that reactions? Peterson-Ulfinations, right? So what is the Peterson-Ulfination? Peterson-Ulfinations, if we see here, condition is a basic. If it is a basic, then syn eliminations will take place. If it is acid, then anti eliminations will take place. These things you should remember in Peterson-Ulfinations while studying in a named reactions. So in basic media it will take the sin eliminations, right? So if you see, first, these both are in sin positions, right? So this bond is migrated here and this bond will leave. First product is here, will get double bond OH BNO. So again it is treated with a MCPPA. So MCPPA, bare Wieninger oxidations. So how it is going to add, this is the most important, whether above the plane or below the plane. If we have a groups, function groups like OH or NH, so if you see this kind of groups, then you going to add, epoxide will form in these positions itself. So we have a this position in below the plane, right? So epoxidations will take place in the same manner. So hydrogens are above the plane, right? This is for what, our product. If you see this NH and OH, then simply you can write the answer which is in present, whether below the plane or above the plane. If it is in above the plane, you can write the answer in above the plane. If it is below the plane, you can write the answer is below the plane. So this is for what, our product. So I hope you understand this reaction mechanisms. If you are not understand, please let me know in a comment so that I'll get back to you. Yeah, this is for what, this named reactions today lectures. I will come in another questions in a next lecture. Thank you for watching this video to everyone. Thanks for your patience. Thank you.